our next speaker is Mr. Stephen Ditmeyer. And Steve has had an extensive career in railroading that started 60 years ago this summer on the St. Louis Terminal Railroad. He received a BS in Industrial Management from MIT and an MA in Economics from Yale. In the private sector, he worked for 6 railroads and a railroad equipment manufacturer. In the public sector, he served as an Army Transportation Corps officer on active duty in the Logistics Directorate of the Organization of the Joint Chiefs of Staff and in the reserves in the 3rd Railway Brigade as an associate administrator for policy and for research and development at the Federal Railroad Administration, acting as general manager of the Alaska Railroad, and as an associate professor of economics and transportation at National Defense University, and as an economist and rail technology expert at the World Bank. His career has cut across multiple disciplines, including freight and passenger railroading, engineering, economics, research and development, policy, marketing, management, operations, information technology, systems analysis, command and control systems, and education. Steve was involved in the creation of Amtrak, the preliminary engineering and economic studies for the Northeast Corridor Project, the establishment of the Transportation Technology Center, the sale of the Alaska Railroad by the federal government to the state of Alaska, the deregulation of the freight railroad industry, the development and testing of the first PTC system, called ARIES, and the development and testing of the first natural gas locomotives at Burlington Northern Railroad, and teaching railway management courses as an adjunct faculty member at Michigan State University, the University of Delaware, and HEC and EML business schools, both in France. In 2015, Trains magazine, on its 75th anniversary, named Ditmeier as one of the 75 most influential figures in American railroading. Steve?
Thank you, John. I appreciate that. I want to thank Fresno State and University of Delaware for sponsoring this conference. We're going to be talking about railroad traffic growth, looking at the future in this presentation. I will put up my presentation. You all have been at conferences. You've heard presentations on precision scheduled railroading. Professor Green just gave a very excellent one on PSR. And you've been to conferences and heard presentations on positive train control. However, I dare say you have not heard presentations that combine these 2 topics. So I'm going to start off. What is precision scheduled railroading? Dr. Green talked about it. I'm going to use the words of the proponents of it. Here's what Hunter Harrison, how he defined it when he was at Canadian National. Precision planning, disciplined execution, synchronized across processes. He wants to focus on the network first, and the mission is to obtain the lowest operating cost. It's key. And he creates service plans that synchronize all the processes connected to the movement of cars. But in doing so, linking operational decisions again to the bottom line financially. And he states, balanced train movement is better for crews and it improves cost control. Notice that there is no mention in what he said, and I'm quoting this from his book, but it doesn't say improving service to customers and improved traffic growth. The Association of American Railroads has defined it. This is John Gray, who's the head of the Policy and Economics Department at the AAR. Again, as Dr. Green said, fundamentals are to reduce the number of handlings of freight cars and containers. Every time equipment's handled, it stops, it's not being productive. Facilities are needed to handle equipment when it stops, and that costs money. Again, a focus here. Costs and how to reduce it. And it costs money when the freight cars aren't being moved. So PSR is going to reduce the handlings and have a network that can move with more fluidity and which has some predictability. That last bullet point there is kind of an important one, and I agree with it. Now, Norfolk Southern, here's how Jim Squires, the CEO, defines it. Shifting operational focus from moving trains to moving cars. He really doesn't go into it, but quite frankly, you move cars by moving them on trains, so you can't really separate it. You have to have a combined, in my view, a combined operational focus on trains and cars. Goal with PSR is service consistency and reliability. Agree, that's really good and important. We want to reduce car miles and improve velocity of operations. Again, those are noteworthy objectives. And he said, we've seen a reduced number of trains on the network from 5 to 10%, depending on the day. Well, theoretically, fewer trains means greater spaces between trains. So there's room for passenger trains in that case. And also, to create fewer longer trains, it takes more time to assemble the train at a yard and time to disassemble the train at its terminal. So time is being consumed, even though you may be running fewer longer trains. Now, here's what Hunter Harrison's successor at Canadian National has to say. It's J.J. Royst. And he said, okay, with precision scheduled railroading, we've cut costs by doing a bunch of things: closing hump yards, selling lines, reducing head count, parking locomotives, parking cars, so on. But he says, look, we can only do so much of that unless we decide to shrink and stop growth and just drive the operating ratio down. And if we do that, we're just going to give up return on investment and potential profitable business. Now, Royst has been focused on growth on Canadian National. Now, again, one reason maybe that congestion and reduced performance of passenger trains has gone down in recent years is that the growth on Canadian National has been tremendous traffic growth coming through the port of Prince Rupert in British Columbia. And that has put a lot more traffic on the main line, and yes, their performance is down, but they are focusing less on the cost-cutting aspects of PSR, and he is focusing more on traffic growth. Here's what Matt Rose, BN's now retired chairman, is saying. He said, look, growth is our focus. Growth is our focus. Cost cutting as part of PSR only goes so far. You have to sweat the assets. You have to make good use of your assets, your physical plant, your rolling stock, and so on, but it has to be part of a balancing act. And this is kind of key here. BNSF balances its management toward benefits among not just investors, but he mentions first, employees, customers, and the community at large. The PSR actually focuses on cutting costs, increasing profits, and rewarding investors with increased stock values. We'll see a little more of that in a moment. But anyway, Matt Rose also says, hey, disengaging from customers to affect our own cost savings doesn't seem to him to be a good long-term business strategy to achieve growth. And as he says also too, demarketing tactics, pulling out of certain markets, stopping serving certain city pairs and so on, can result in unanticipated but logical bad public policy outcomes. Now, here's what Matt Rose's boss, BNSF's owner, Warren Buffett, has to say. He says, we'll see, we've watched it plenty, but he's noted that PSR makes the customer adapt to the railroad more than the railroad adapting to the customers. And he said, but practically everyone has done PSR. It's improved margins dramatically. But on the other hand, we at BNSF have gained market share because the railroad customers apparently like us better. Over the long term, we'll see. It's not like this is something we can't do. But anyway, fascinating. Now, what happened then when Hunter Harrison went to CSX? He went from Canadian National to Canadian Pacific to CSX. And he decided, I think he felt that his lifetime was short, and it was, but he would act quickly. So he cut 10,000 jobs from a workforce of 31,000. That's almost a third. Converted 7 of 12 hump yards into flat switching yards, closed the shops, tore up second tracks, reduced the car fleet by 30,000 and locomotive fleet by 900. Again, like Norfolk Southern, as Jim Squire said, fewer longer trains. The train length went up 12.5% on CSX. As a result, there were bad derailments. The town of Hinman, Pennsylvania, just north of Cumberland, Maryland, had not one, but 2 of these giant trains derail in their backyards and did major damage to this small town in Pennsylvania. Collisions, the KC, South Carolina collision, so on, where crews were preoccupied with, they were shorthanded and preoccupied and failed to throw a switch properly. Amtrak lost 2 crew members as a result of that. Harrison closed some intermodal terminals and service lanes. Demarketing, stopped serving certain city pairs. They weren't producing a big enough margin. As a result, there was extreme customer dissatisfaction, and they complained to the Surface Transportation Board, and they held a surface transportation hearing on CSX matters in 2017. But now, if you all are old enough, as Paul Harvey used to say, but let's look at the rest of the story. Hunter Harrison on CSX cut costs dramatically and reduced the operating ratio from 69.2 to 57.4. Staggering reduction in operating ratio. And as a result, there was a significantly higher stock price. $10 billion was added to the market value of CSX during Harrison's tenure. And as a result, multi-million-dollar bonuses were paid to Hunter and to other senior executives there at CSX. It's this bottom bullet item that explains why PSR proliferated elsewhere in the railroad industry. Other CEOs said, if Hunter Harrison can make that kind of money by cutting costs and with so-called PSR, we want to participate too. The bushel barrels full of money that have been thrown to executives as railroad stock prices have blossomed because of PSR is what is driving it at it. I am quite confident that Tony Hatch after lunch will be talking some about that in his presentation. Now, what did customers have to say about precision scheduled railroading? 2 years after the Surface Transportation Board hearing on CSX, they held a general one on precision scheduled railroading in May of 2019. It was supposed to be a half-day hearing. A lot of shippers applied, so it got extended to one full day, then to 2 full days. And the railroads that came, by the way, I attended. The railroads that attended said, look, precision scheduled railroading is neither precision nor scheduled. This is customer after customer after customer. No customers defended the railroads at these hearings. They say service has deteriorated since PSR was implemented. Less frequent setouts and pickups at their plants and factories and facilities. And that when they did occur, they were irregular. They promised them at certain times on certain days, but they never were at the right time or on the right day. And they said, look, not only is service deteriorating, the railroads are charging us more for increased demurrage, storage costs, and shipping costs. And they said, furthermore, because they are coming less frequently, they're delivering larger batches of cars to our facilities, we've had to pay our own money to install longer sidings to hold these bigger batches of cars. And because they're not coming very frequently, they're charging us demurrage for the cars that we are having to store. And these customers said, look, we're concerned about our own supply chains, our own ability to supply goods to our customers. And so we're having to pay more, but we're shifting wherever we can to trucks to get better service. So on some of these railroads, there has been a deterioration of freight traffic. And this was before the pandemic and before the economic showdown. But this is running counter to the idea of traffic growth in the future to keep railroads healthy. So how does a railroad management resolve this situation? It turns out that the railroad industry has just spent over $10 billion on positioning, communication, sensor, and computer technologies that provide continuous real-time information that should enable them to run trains on schedule with precision. And these technologies comprise positive train control. Now, PTC had been considered for several decades, like about 4 decades. But in the 1980s and early 1990s, Burlington Northern Railroad, where I was working, we developed the Aries PTC project and demonstrated it for 5 years up on the Minnesota Iron Range. And at the same time, the AAR was working on its Advanced Train Control System PTC project, which was very similar. Aries used GPS, ATCS used transponders, but conceptually they were very similar projects. But anyway, our management on Burlington Northern, we all recognized that the safety benefits alone would not justify the cost of implementing positive train control. So, but my management, my chairman, Dick Bressler, said, look, is there any way that this technology can get us business benefits, efficiency benefits? And so we did analyses. And here's what both we on BN and the AAR found. You could get, with this same positive train control technology implemented properly, you get improved running times and with reduced fuel consumption and emissions. You could get improved running time reliability and schedule adherence. Bing, that's what's needed for precision scheduled railroading, I believe. And you could get improved utilization of assets. And your assets are the mobile assets were locomotives, cars, and train crews. But also you could get improved utilization of your infrastructure, increased track capacity. You could get increased efficiency of track maintenance operations. How? By allowing the maintenance crews to look into the tactical and strategic traffic planners to see what their windows are, and they could see if there were sufficient windows for them to get on the track. And if so, they could request it. The dispatcher and the dispatcher's computer would issue the authority, and so on. And so there was less waiting time, and the maintenance crews would have more useful time on the track. We'll get into a little of that later on. And finally, having real-time information on the location of trains and the cars on the trains, and better predictions then of arrival times, gives better communications of shipment status to the customers. The customers not only want their goods, but they want to know when it's coming. Trucking companies can give better estimates on that than railroads currently do. Now then, the Railroad Safety Improvement Act of 2008 mandated the implementation of PTC systems. That was because of not one, but two railroad accidents that occurred. The first was the collision at Graniteville, South Carolina in 2005. A local freight train pulled into a siding to park for the night. The train crew forgot to throw the switch back to the main line because this was dark territory with no signaling. An approaching train came, ran through the switch, misaligned into the local train that had chlorine cars. Chlorine gas escaped, went into a textile factory nearby, killed numerous people. It was immediately after that, not immediately, but some months after that, that Congress started working on drafting the Rail Safety Improvement Act, including a PTC mandate. And in early 2008, it passed both the House of Representatives by a significant majority, bipartisan majority back then, and it passed, in a slightly different version, the Senate by a significant majority, bipartisan. So when Chatsworth collision occurred between a Metrolink commuter train that ran through a red signal because the engineer was text messaging and not looking, and it collided head-on with a Union Pacific freight train and killed 25 people. It was immediately after that Congress said, what do we do about this? The Senate decided to amend the version of the Rail Safety Improvement Act that it had passed to conform with the House version. And so there was no conference committee required. They sent it to President Bush and he signed it just a little over a month after the collision. But it had that language for PTC mandate had already been approved by both houses of Congress before Chatsworth. So anyway, what did the Rail Safety Improvement Act require from PTC? It said PTC must prevent train-to-train collisions, overspeed derailments, incursions of trains into established work zones, protecting the roadway workers, and prevent the movement of train through a switch left in the wrong position. That is, prevent Graniteville. But what was interesting is these were performance requirements, not design requirements. And the bill did not instruct FRA to write design requirements. So FRA wrote performance rules with these four categories of preventions and PTC, and required railroads to submit paperwork on how they would implement their PTC systems to accomplish this, and then inform FRA on that, and FRA would then approve or disapprove of their plans. But bad things happened to PTC in the following year. What happened then? Railroad CEOs decided to assign PTC implementation to their signaling departments. And the signaling departments decided to replace their old wayside signals with new wayside signals and then overlay PTC on top of them. The railroads applied to FRA and were granted relief from certain requirements, like knowing where the ends of trains were. They said, oh, it's too expensive and we don't need that. And besides, if you don't know where the ends of trains are, they'll be just low-speed accidents. It's interesting because the law did not specify any efficiency improvements to accompany the safety improvements, because after all, it was a Rail Safety Improvement Act. The railroads industry decided not to implement any efficiency improvements. As a result, this putting in new wayside signals to replace the old ones and overlaying PTC on top of it, that doubled the cost of PTC implementation. And by tying it to the wayside signals and fixed blocks and the relay logic, they basically eliminated the business benefits of the type that I mentioned that BN Railroad and the AAR had forecasted 20 years earlier. So I will say to you that I believe that PTC systems as currently being implemented on most railroads have shortcomings. Because they're tied to fixed blocks and wayside signals that use relay logic, train spacing is fixed based on signal spacing. Trains cannot run closer together safely. The movement authorities and work authorities are still being conveyed by signal indications, not by digital messages. And PTC information on train location is not being integrated with information on locomotive health, on work order reporting for setouts and pickups, for track forces terminals that tell where the maintenance crews are in real time, and the automatic equipment identification train consist information. Those remain very separate. And PTC is not being integrated with tactical and strategic traffic planners and energy management. The tactical and strategic traffic planners would be at control centers, and energy management systems would be on the locomotives. Now, there is one major railroad that is integrating these systems all with PTC. And that, no surprise, is BNSF. Some of the other railroads are implementing some of these other systems, are implementing them, but they're not integrating them with their PTC things. They say PTC is safety, efficiency things are separate, we don't combine them. Now here, there is, again, Paul Harvey, the rest of the story. I got data yesterday, and I don't have it on the slide here, but I talked with the Federal Railroad Administration and got some statistics. And even the imperfect PTC systems that I described here are still having a very significant reduction in these PTC preventable accidents. And so PTC is working, and I said, FRA, you maybe deserve to take a victory lap on PTC, because on the safety side, it's working. Now, in my view, the challenge is to get PTC working on the efficiency side. So what is next-gen train control? I've introduced right here a new term. And the short definition is what comes after our current PTC implementations. Now, as I mentioned, the railroad and FRA people who worked on PTC after the law got passed and the mandate got issued, they define PTC as a safety-only, non-vital overlay of wayside signal systems. My definition of next-gen train control systems is that they are vital, standalone systems separated from the wayside signals, but integrated with other intelligent railroad systems. and there you can both improve on the safety of current PTC systems, and you can increase the efficiency, traffic growth, and profitability of railroads well beyond the little that, if any, that one achieves now. But again, looking ahead, and our title of this conference is Traffic Growth for Railroads, and I will argue that it can be accomplished with these systems. Now, little aside, again, a digression, there's next-gen air traffic control that the federal aviation and the aviation industry is implementing in our airspace. And next-gen air traffic control and next-gen train control are basically equivalent systems. They both use continuous real-time information transmitted over digital data communications network. They use GPS positioning with WAS augmentation, that's wide area augmentation system, to get 1 to 2 meter positioning accuracy. Very precise accuracy. You know which track the train is on, you know that it's clear of switch, that you have appropriate switch clearance, and so on. Additional sensors in both systems, train and air traffic, new onboard and control center computers, and textual as well as graphic cab displays that focus on situational awareness. So, what should the railroads do to their PTC systems to achieve next-gen train control to improve safety and efficiency? I've given some hints already. One is make sure that they know the location of ends of trains, in addition to the front ends, so that they're known to dispatchers and train crews to prevent fatal rear-end collisions. They keep occurring. Red Oak, Iowa, Truxton, Arizona. And the law did not say prevent head-on collisions, it said prevent all collisions. And so you need to have end of train information. There are a couple easy ways to do it. GPS receiver on the end of train device is one way to do it. The other is to use the UMLR file that has, you have your train consist from AEI on board the train, and so you know what cars are on it. You connect with the UMLR file, Uniform Machine Language Equipment Register, to get car lengths, so you have the length of the train. If you know where the front of the train is and you know the length of it, you know where the rear is. So it's easy to do, and it's not expensive, but it needs to be done. We need GPS receivers and data radios, track forces terminals on maintenance of way vehicles and machines and inspectors to make sure that dispatchers and train crews know where they are. If you recall at Chester, Pennsylvania on Amtrak a couple years ago, the newly on-duty track supervisor forgot to ask for a work authority from the dispatcher. The dispatcher forgot to ask the track supervisor if he needed authority. By the way, this was a whole weekend track work project. And because the dispatcher could not see where the backhoe was, he didn't know that it was there and fouling a track, gave the clearance, the movement authority for the Amtrak Palmetto to come through at speed. Big collision, the 2 track workers died. Third, you have to install track position sensors on all switches, not just powered, but also manual switches, to prevent the Graniteville collisions and the Casey, South Carolina collisions. It's important that a train and the dispatcher know the alignment of all switches so that he can give the movement authority through those switches. Finally, incorporate intelligent grade crossings into PTC systems. Intelligent grade crossings. This is giving people at all grade crossings information on when the train is going to be arriving. Now, we have gates and lights at some, but we also have private crossings at others. And we also now have autonomous road vehicles showing up. And autonomous road vehicles, especially at crossings with only crossbucks, won't know that they have to stop at a grade crossing. So you have to have radio communications with road vehicles. But also too, with intelligent crossings, you have sensors at the crossings to detect whether there are stalled vehicles, either maliciously or accidentally stalled vehicles blocking a crossing so that the train can stop in time. Most of the grade crossings on the private railroads in Japan, where there are a lot of crossings, have sensors to enable trains to detect when their crossing is being blocked ahead of them. Couple more new things for improved safety. The railroads really do need to write new simplified rule books for next-gen train control. They should have done it just for their current PTC, positive train control implementations, to replace the existing NORAC and GCOR rule books. By the way, the railroad industry actually made a conscious decision in 2009 that they weren't going to change their rule books, that PTC would have to fit within the existing rule books. Not good. I argue that there is that next-gen train control where we separate from wayside signals, that we have a new paradigm of train operations where there's continuous real-time information on train location and speed, and that then changes the operating rules and actually simplifies them. We need to investigate systems for detection of broken rails. Currently, where we have track circuits for our signal systems, that they detect location of a train, that there is or is not a train within a block, or that there is or is not a broken rail within a block. If we use GPS for train location, GPS and WAS, we don't need the track circuits for the train location purpose. And there has been work done on using fiber optic cables stretched and tied to the tracks under the railhead, that when there is a fracture of the rail, it breaks the fiber optic cable and it will be able to tell the system exactly where the rail break is. So that's a lower cost way of doing it than with track circuits. And finally, there need to be improved cab map displays, especially on passenger locomotives, and I'll show you why in just a second, showing track profile and alignment for situational awareness to prevent the Philadelphia, Pennsylvania overturning accident about 4 years ago, and the one in 2017 at DuPont, Washington, with the Talgo train on a new route that again overtrained and fell on an interstate highway. But both were overspeed and the train crews lost their situational awareness. Now, here are the cab displays that you will find on Amtrak trains and on freight trains that are running on Amtrak trackages. On the right is the access display, Advanced Civil Speed Enforcement System. On the left is the incremental train control system. You don't get much situational awareness from these displays that are currently in use. Now, the engineers that use these know how to interpret them, and it tells them how distance to target, time to a penalty application, maximum speeds, and so on. But it doesn't provide real situational awareness. Now, on the freight railroads, they all went with the IETMS PTC system, Integrated Electronic Train Management System. And Amtrak trains that run on freight railroads have to have the same cab displays. And there's much better situational awareness with these IETMS displays. Over on the left, upper left of the graph, you'll see a long rectangular white block, that is the train. And that train sort of stays there and the track moves under it. And you have gradients, you have curvature shown, you have grade crossings, you have mileposts, station names, warning devices, hotbox detectors, and all kinds of things like that shown. But you get much better awareness. Now, I will also say, I think this particular diagram could use a graphic designer to rework this and make it even better. Now, moving from safety to efficiency, the railroads need to integrate PTC with train consist information from the AEI system so that the railroad, the train, the dispatchers, and even customers have information on the location and speed of trains and locomotives and cars and shipments so that customers know that their train is moving instead of on a block that it's somewhere between Barstow and San Bernardino. They know exactly where the train is and what speed it's moving at. And that then, this information provides for better forecasts. Talk about that in a moment. You want to implement track forces terminals so that continuous real-time information on location of the maintenance vehicles is available. We needed that for safety, but we also need it for efficiency so that the maintenance crews can check with the strategic traffic or the tactical traffic planner to get their windows, and that they can automatically select their windows with the dispatcher's permission and so on. But we're talking about here moving the management of maintenance of way operations on the track to being the same as the way operation. Up until now, and in fact, probably now, they are managed differently. One is through signals and voice radio communication, and it needs to be better. There needs to be better of opportunities for maintenance of way crews to work and better knowledge of where they are working to protect them from trains. We need to decouple PTC from wayside signal systems and fixed blocks and implement moving block operations that provides flexibility of operation and abilities to recover time and so on. Not always necessarily with increasing speeds of trains, but we're improving the running time of trains. We want to transmit movement authorities and work authorities digital, not by signals or voice radio, but by digital communications, and they are both, can be done textually and graphically both. And we had demonstrated that 35 years ago on the ARIES program in Minnesota. Now, also for improvement efficiency, railroads need to integrate with additional intelligent railroad systems. On board locomotives, they need to install locomotive health reporting systems that provide the status of the dynamic brakes, that show the engine output. Is the locomotive producing full power, or is it crippled and running with reduced power? That kind of information is needed, especially in mountainous terrain, to know whether or not you have sufficient horsepower on the locomotive to get over the hills. You want to have an energy management system providing guidance to the train crews, locomotive crews on proper throttle and brake settings to optimize fuel consumption while still meeting schedules. And you need a work order reporting system to tell train crews what cars to set out and pick up. And when they acknowledge that they have done that, it changes the train consist information on the train, at the dispatcher's office, and in the railway operating data system. For the control center systems, you want to have precision dispatching. You want to have tactical and strategic traffic planners. By the way, if you're not familiar with a strategic traffic planner, the Federal Aviation Administration has one out in Manassas, Virginia, for the entire airspace over the United States. It has the big picture, and it shows where everything is now, and it can also show where everything will be at times in the future. And it can see whether congestion is going to occur at certain airports. It can tell whether bad weather is going to reduce capacity at certain airports. And it can use this information, taking this whole strategic view, and manage the operation and deal with that. Gate holds, reroutings, alternate landing fields, and so on. And it was at that center that the 9/11 incidents were handled. When the decision was made to shut down the airspace system, at this strategic traffic planning center, they could direct aircraft to certain fields where the capacity remained on the ground in order to handle that. But we want to have locomotive, car, and crew scheduling systems. Crew scheduling is important to improve the life of our train crews. Our freight train crews quite often are not randomly scheduled, but by seniority, and end up having rotating sleep schedules and life schedules. And quite often train crew members can't make their daughter's high school graduation or their niece's wedding or things like that. Our labor relations people on Burlington Northern said, my God, if you can do crew scheduling with scheduled trains, you can really improve the life of our employees, and it will actually decrease wage pressures on us. Finally, crew registration and timekeeping systems. You want to know when crews take over their train, when they leave a yard, when they arrive at a terminal, and when they vacate their trains, because pay is different during those different times. And that comes with this, and it's quite inexpensive to implement. So what do you need, though, to do on a railroad to successfully implement next-gen train control? It can't be done without total support from the top officers of the company. The chairman and the CEO have to let it be known that they want this to be done. They have to provide the resources, the capital. They have to provide the staffing resources. They have to reward the employees on this assignment. We had a case, by the way, on one of the big railroads back in, I think it was maybe 2010, large railroad with yellow color, where the president said, PTC is the worst thing that the government has ever done to the railroad industry. It's a waste of time. It's a waste of money. We shouldn't do it. And at the same time, he had people working on the project. Were they enthusiastic, or did they feel empowered to do a good job? I don't think so, but that's the way it happened. And he left shortly thereafter. But so the top leadership is so key on implementing this. Also, too, though, the railroad has to include their union people in planning next-gen train control. Got to talk to them, because these are the people who not both, but who will install it, maintain it, and operate it. And again, on these recent PTC implementations over the last decade, union people were cut out quite often and didn't know what was going on till the very end. And they heard rumors that PTC was going to lead to smaller crew sizes and so on, and said, no way, we don't want that. You need to have an implementation team consisting of representatives from every department that are going to be affected by it. And here I have the list. I won't read them all, but you can see it. Going to next-gen train control affects basically all of the departments of the railroad. Think back in history. There was another technology that affected every department on the railroad, and that was the replacement of steam locomotives with diesel locomotives. All the departments were changed. But anyway, also one has to plan on training, training, training. You can't just throw this hardware in and software. You have to train people to use it. But it's doable. And you have to test it to make sure that it's operating with the specifications that you want to achieve, these business benefits and the new safety benefits. I debated whether to put this slide into the very beginning or at the very end, but if you want to run a true precision scheduled railroad, you need to know certain things. And by the way, I believe in running a scheduled railroad, not just running fewer longer trains, however. I think you can do it with fewer shorter trains and still have room for passenger trains. But anyway, what you need to know to run a precision scheduled railroad, you need to know historic data, where mobile assets were in the past, and you need that for billing and payments and doing analysis. Now, if there's one thing that railroads have been doing for a long time, when I joined the St. Louis Terminal Railroad in 1960, they had already had mainframe computers for several years, keeping track of this kind of information. So that, railroads know how to do that. But what they don't know how to do is make use of continuous real-time information. That you need sensors on mobile assets. And by the way, mobile assets do include people, but you need to know that your mobile assets, locomotives, cars, and crews, that they're service-worthy, that they're in fine shape to go out on the road. You need real-time information on the status of your fixed assets. Is the infrastructure train-worthy? The tracks, the switches, the bridges, the tunnels, you name it. Is the infrastructure, the embankments, is the infrastructure train-worthy? And you need to know that in real time. You need to know where your mobile assets are and what they are doing. That's what your GPS and data radios do. And they can tell you precise location and speed of where the mobile assets are. Now then, also you need to know where these mobile assets need to be at a future time. But that doesn't come from these systems that I've been talking about. That comes from the marketing department, who has talked to the customers and they have reached agreements on when the cars are to be delivered. Hopefully marketing works with operations planning to do that. But you have to have a plan and a schedule for, and you want to know with continuous real-time information where these assets need to be at a future time. Then you need forecasts. Where will the assets be? The trains, the cars, where will they be at sometime in the future? And you need real-time information, not historical information, to do accurate forecasting. You can't use 2-hour-old, well, the train left Barstow at 10 a.m. and, or I'm sorry, it's, let's go earlier, 8 a.m. and be able to forecast when it's going to arrive in LA or at Port of Long Beach. You need better information real time, and it gets updated as train movements occur. But then you also need the forecasts on here you need railroad management thinking with the best information. How to get the trains and the cars from where they are and where they will be to where they need to be. Little aside, this is what air traffic controllers and airline dispatchers deal with just the same way. But also, to run a true precision scheduled railroad, you need to know that the correct movement and work authorities are being conveyed to the right crews and the right vehicles, and that they are being complied with. That's a key part of any command and control system. So, final thoughts. This is Ditmeyer saying this. But I will say that a properly implemented next-gen train control system will get the right information to the right people at the right time. To enable it to run a railroad on schedule with precision, safety, efficiency, and profitability, and to support the railroad's customer supply chains with improved visibility and service, improved data quality, improved information. And then also too, on the railroad itself, you want to make sure that your people get all of the information that they need in order to enable them to do their jobs well. But you don't want to overburden them with excess information. You don't want to have them have to look for the information you need. You want to have it presented to them in such a way that they can use the information they need to do their jobs well. So with that, I will ask, are there any questions? If you want any more material on any of these topics, you can email me, call me, or write me. I have to now leave this screen in order, I think, to be able to answer any questions that you might have. Oh, and there's Victory Bulldog from Fresno State, and here's the Blue Hen from University of Delaware here saying hi, and hope you have a happy lunch hour, okay? Although Victor doesn't appear to be nearly as happy as the Blue Hen. Okay. Well, let's see here. There, I'm back. Let's see if there are any questions and answers.
I got a question, Steve. This is Jim. Yeah, how long do you think it would take to put out a commercial, I don't know whether we call it version 2 of positive train control or your next trend, whatever the nameplate's going to be. How long to take and develop that as a commercial product? Are we talking 3 to 5 years? And what do you think the cost might be? Capital investment? Because you're going to have to develop some combination of software, skill sets, training. And then who do you think is, what 1 or 2 railroads do you think might be the first leaders to step out? Got any hints on that?
I mentioned that BNSF is actively engaged in this as we speak. They have not given me a target time. It's obviously a multi-year program, in excess of 5 years, I would say 5 to 10. I would say that it will cost significantly less than the $10 billion that's already been spent on PTC. I would say on the order of 4 to 5 billion, maybe. But it's hard to say, and railroads may not want to do all of the pieces that I described here, but it is doable. I have a little comment here that from one of our attendees, anonymous, who's talking about the fact that there's that people who have worked on the EU version of next-gen air traffic control have are now working on train, railroad train control issues. I'm aware that in Europe, the European train control system has already shifted from transponders. Not shifted from, but it previously was mandated to have transponders between the rail for train positioning. Now they have authorized the use of GPS or Galileo satellites, and they have a system called EGNOS, which is the same as our WAS system. So that, and Europeans have backed away from using GSMR, mandating GSMR, but rather having a different communications architecture where you could use GSMR, 5G, 4G, LTE, even SATCOM and what have you. So there are steps being taken in Europe to increase the flexibility of their PTC implementations called Erdemus, and to actually reduce the cost, using GPS or Galileo rather than transponders is a significant cost reduction for them. So but anyway, that's my time. Again, I have a limited experience. I saw so many of these things done on a 5-year demonstration of the Aries PTC system on the Iron Range that incorporated the locomotive health monitoring, the AEI information, the work order reporting. We were developing strategic traffic planner and tactical traffic planner. Those were all done. By the way, on locomotive health monitoring, the cost of that is way down because virtually all new locomotives, high horsepower locomotives, road locomotives, come with onboard sensors, but they are designed to be downloaded when the locomotive arrives at the locomotive shop. Tying this in and having it tied to the data radio system on the locomotive to send this locomotive health information is a relatively cheaper implementation. So I would say maybe that, I hadn't thought, but my estimate of 5 billion is too high, probably, or like 3.
So for the engineers, particularly the young students that are here, sounds like there could be a role for a data integrator, somebody to integrate these various systems if that's what they're looking for as a job opportunity. What's your comment there?
One word, absolutely. I agree completely. Except they have to clone themselves. We need multiple people of this ilk to do that. And the demand is high, no, the demand should be high.
Should be high, yes.
Should be high.
Thank you.
But anyway, I want to thank whoops, let's see, there's, what is the role of policymakers and a possible new administration to incentivize what you are talking about? Here's an issue with FRA. FRA is primarily a safety regulatory agency. And so it's hard for FRA to encourage railroads to do things to improve their operations, to improve their efficiency. However, in the late 1970s, FRA did intervene by deregulating the freight railroad industry because the railroad industry was dying then. 1/4 of the trackage in the United States was in bankruptcy at that time. And the the government saw that there were only three opportunities. One was nationalization of the railroad industry. The second was massive subsidization of the bankrupt railroads. And the third was deregulation. And it was deregulation that won out in that debate. So FRA could, but it just depends. All I'll say is it depends. And if Congress is concerned about railroads these days failing to support their customers, the manufacturing industry, the agricultural industry, the chemical industry, the timber industry, and so on, Congress may want to enact something to provide money. I don't know how to judge that. Another question is, what are projected annual maintenance costs forecast to be as a fraction of the PTC capital cost? When fully active, I would say that the maintenance costs are no greater than current maintenance costs for locomotives and signal systems and things like that. The maintenance on PTC systems is done separately, is done differently. These are electronic boxes that have self-diagnostic equipment in them. Boxes are swapped out, sent off to a place for repair or replacement. So that's easier. By the way, it could be that the improved productivity of track maintenance crews with this, what I call next-gen PTC, could actually provide some massive improvements in productivity and cost savings there without laying off any people. Again, that would cause me to think that it would be that it might be a wash. I'd have to think a little more before I swear to these comments, but this reflects my current thinking.
Okay, thank you, Steve. That was a very informative presentation that described a way forward using technology to improve our current PSR environment.